Internet. I am Nate, and this is my research and development and mad science world in Factorio. Last time I showed the adaptive load balancing furnace array, which you see here, and this time I'm going to get into the more mad sciencey side of things. So what we're looking at is the steel and stone brick version of the load balanced furnace. And the reason this one is so complicated is it prevents deadlocks. And for those who aren't really familiar with the issue or Factorio in general, this is what we get into. For copper and iron, the recipe only involves one item, so it can complete a full cycle no matter how many things you passively feed into it. However, when you move up to steel and stone brick, they both take more than one. Stone bricks take 2, steel bars take 5. And so if you do not fully load a furnace with enough to cycle all the way through, it will just stop. So in this case, we have a deadlocked furnace. You can see it has a single iron plate in it. The loading conditions on these smart inserters and smart chests are there to load multiples of what the furnace needs to work. However, in this case, I don't have the 5th level of inserter stack bonus, and that is preventing this from working. If you do have the 5th level of inserter stack bonus, it will work, and this will passively load this furnace. So this is the most elegant way I've seen to do this. I think I saw this on, and I'm going to get this name wrong, but I think it's Mullematsch's YouTube channel. I think that's the name. I'm sorry if I'm pronouncing that wrong. It's pretty simple. All it does is it loads things into the box when it's got less than the stack size it needs for one cycle, and it takes things out of the box when it has exactly the number it needs for one cycle. But in this case, it won't work for me because I don't have the full inserter stack bonus. The stone side would work just fine if it weren't clogged with this iron plate. So if I take the iron plate out, it will start producing stone, and we've broken the deadlock there. So that is the issue. Basically for lower tech people who don't have the full stack bonus, that isn't possible without mods. So what I did is I created a version that works at lower tech levels. It has a little bit more complexity. So if you need a place to get rid of all your extra combinators, this might be something for you. It is not efficient. It has low throughput, but it is highly controllable, and it is demand based, so it fits in with the rest of my network, but it's most certainly not a practical thing to do. So the way this works is it will take the ingredients out of these containers as it needs them. These are small buffers because it needs to load quite a few at a time. And the way it receives demand from the load balancer, and if it's told to make steel, it will start loading on this side. It will trigger the loading of this intermediary box here when it first gets the demand, and then it will trigger the stopping of loading when it reaches in this case 40, which is the number I need to fully cycle steel through the system. And then it will release the circuit. Once it is fully cycled, it releases the circuit back, and stone could be made if the demand signal had changed. In the case that the demand signal does not change, it'll just keep making iron or steel for as long as you do keep a demand on the network. So let me show how this works. Get up here to my control here. So let's say I want to create some steel. Just like the other load balancer, this one takes demand and balances it between two items. However, in this case, it does not have the granular control of the upper one. So it is only going to load balance when I actually put demand of multiple things into it. So right now it's making steel exclusively. You can see it cycling through here. If I now add some demand for stone bricks, what's going to happen is after this cycle completes, over here, this one will switch over to stone and start that cycle. But you can see how it waited until this one had finished before it started this one over here. And the steel or the stone side works exactly like the steel side in that when it finishes the cycle, it real briefly releases control, and if the demand has changed, it will switch. Otherwise, it will just keep making stone. The stone side also produces many more stone bricks at once because it takes less ingredients to make stone brick, and we need to have a similar amount loaded per cycle. So there's 40 iron plates that are loaded for a steel cycle, and I load 48 stone for the stone brick cycle. The reason for that is if one of these cycles is much shorter, since it released control right there, at that point, if this one would have started spilling over, it had the slight chance of them colliding and mixing. So that's why they need to be approximately the same size. So let me get past this. The way the balancer circuit works is the exact same one as up here with the other furnace. It's laid out in a row here, so it's a little easier to understand. The first one figures out the ratio that we need to produce things in. The second rounds that out so that we get a more precise number. And then the final one figures out how many of each to actually produce. The furnace by default says everything is steel, and so this calculation is figuring out how much of steel to give up to produce brick when the calculation says it should. And then feeds all that into the network. So you can see we've got 3 green, 1 yellow, and those correspond to the furnaces. So if the green ones trigger a furnace to produce steel, yellow triggers a furnace to produce stone or stone brick. And then the other signals just say you need to start producing it, because there will always be a green signal on the network. All right, so as far as what these circuits are actually doing, and these could probably be simplified a little bit. I added a couple fail-safes at the end that may have made some of the earlier ones redundant. So there'd be a little bit of testing needed there, but I haven't taken the time to do that. The RS latches here, or SR latches, are what allow it to set one side to run and then turn off that side when it's done. So it's going, and then these are pulse generators that make the latches work when specific conditions occur. So when this box runs out, it triggered the pulse generator here, which triggered the latch. So it's got quite a bit of circuitry. Then this top one here, this makes the network prefer steel to stone brick. And the reason for that is if the signals come across the network at the same time for steel and stone brick, it will try to start loading them at the exact same time, and it can create a conflicting condition with loading things into these boxes at the same instant. This basically delays the response time of the stone side just slightly and allows steel to take precedent. And as you can see, it is slow. The one thing I could have done to speed this up, which I realized after I built most of it, was I could have spread these out a little bit more and loaded more into these counter chests. at once. I could have essentially used multiple loaders to feed this system, and I may do that eventually, but again, this is not a practical design. It's more just a let's see if I can do it type design. All right, so actually I think that's about all I have. I think that kind of explains this. I will probably put up the blueprint for this if anybody is masochistic enough to use it. It will be available. All right, thanks for watching.